Alright, we should be live. So today, it's gonna be amazing. What we gotta do, we're gonna build our own NFT. So we're gonna build ERC721, which is a standard of Ethereum. And we're gonna build this token, and if everything goes well, we will try to deploy it or list it on OpenSea. So we go through the whole process. It's all gonna be on Rinkeby test network. So, you can get fake Ether there and you can play around, try it as well, and follow along without risking any real Ether. So yeah, so that's that. Let's start, I guess. Boom. Let me open this bigger. So first thing first, I'm just gonna build it from scratch. So to start, let's just create a new directory here. Let's call it BeaverNFT. It's because it's Beaver Codes, it's the name of my channel, it's the name of my company, and yeah. And if we go to this new directory, I'm using Truffle. I've done few videos before where I talk about Truffle some more and what it's good for and how the structure works and so on. But for this, let's just assume and trust that it works. So we can do Truffle in it to get the basic template generated, or like the file structures. And then if we do code dot, this will open our VS Code. Again, I'm assuming you have a VS Code installed. You don't need to use VS Code, you can use whatever you want. But I like VS Code. So this opens text editor, this case VS Code. It also created a bunch of files for us. We're not gonna worry too much about tests in this one, but obviously smart contracts, when you deploy them on chain, you can never change them. So the least you can do is write a good unit test coverage to kind of verify what you've written is gonna work the way you expect it to. But you always get this migration smart contract, which kind of keeps track of which contracts you deployed already, which you didn't. That's not too important for us. And then you get this Truffle config. We're gonna get to this later on, but for now, let's just look at this. Oh yeah, I kind of jumped maybe too far ahead. So I said we're gonna do ERC721 token, which is one of the NFT standards. What are the standards actually for? So over the time that the blockchain's around, and especially in this case Ethereum based blockchains, EVM compatible, meaning you write code in Solidity, for instance. There are different programming languages you can use, but Solidity is one example because it gets all compiled down to bytecode. So this is a higher level abstraction than the actual bytecode that runs on the EVM. Anyways, the way how you do this in EVM, these tokens, you keep them, you create some sort of contracts which are kind of classes, and then they have internal structure and they have some methods. And over the time there's this standard ERC721 which kind of all the NFTs implement, and then all the marketplaces know how to trade these NFTs. So basically that's the good reason, one of the good reasons why you should use the standard, because then you can list it on any marketplace as well. That's the benefit for you. Another cool thing is, because these standards were around for a while, they're pretty good. Like they're pretty well tested by other people's. They written their contracts, and they kind of work. They cover the use cases you would expect, and they and there is a smaller risk that you're gonna make a mistake. So what we're gonna do again this time is we're gonna try to write our own, just like start writing it, and then we're gonna switch to some more standard way of doing it. Cool. So last time I did this, I've actually did a similar standard, which is ERC20. That one is for fungible tokens. So not so fungible token is what you can think of cryptocurrency. Like I've been lately looking into some metaverses, so there's a Decentraland and they have a cryptocurrency called Mana in the game, and that's ERC20 token. So let me just create a new file here. Boom. Okay, so let's set up the file. I'm gonna keep talking afterwards, sorry about that. So first line, you need a pragma file here. What did I write here? Boom, pragma, solidity, and then version. If you don't know your version, so this tells the compiler, which is the thing that takes this solidity code and turns it into bytecode that later can run on the blockchain. This tells it what version of solidity it should use to translate it, because the versions, they change support for different tools, they enforce different stuff. So one easy thing, if you're not sure which version to choose, is you just gonna look at what version you are using at the moment. And there's because we're using Truffle, we're gonna use Truffle to also compile these contracts. So we can look at what Truffle is using and just put that there. So you can do Truffle version, and it should list a bunch of versions, including the Solidity compiler version, which is this. So you can take that, put it here, and we're all good. Cool. So next one, we're gonna write this BeaverNFT. What we're writing right here. So this is the basic construct in Solidity. This is the contract. This is what you're writing. That's the smart contract. So even NFT or cryptocurrencies, they are also smart contracts. They just happen to adhere to some standard. So then we call them, cryptocurrency or NFT. But they don't need to implement these standards for it to practically be an NFT or fungible token. But that's just what people call them. So this is a contract. You write all your, if you're coming from object-oriented programming, this would be your class, I guess. You can write fields or functions inside it. It has a constructor. We're going to use those things. And then when you do a deployment of this contract, you think of it as creating an instance of this class and you put it on the blockchain. There's nothing stopping you from taking this class again, this contract, and creating another instance like next day, right? But then of course the uniqueness of the thing that you created is not there because you have two contracts and they both have the same tokens, so you need to kind of figure out how it is. Normally, if it's a part of some bigger application, your application would have a link to the correct contract that you're working with. And if you build a new contract, then you would point to the new contract. But with the NFTs and the ERC20, the fungible tokens, the problem is that the responsibility of these smart contracts is to keep ownership, like who owns what, right? And if you create a new instance, it obviously doesn't have that mapping anymore. So you need to think about it. You either need to kind of transfer the ownership in some way, or you need to ask people, like build a thing in your new contract that would enable people to like claim the NFTs if they have them in the previous contract. So it gets kind of confusing. Anyways, so this is the contract, and then we're gonna start doing something. So it comes down to the data structure that you wanna keep things in. If we would be, let's talk about ERC20 for a bit, which is the fungible token, aka cryptocurrency. If you would use that, I'm just gonna talk about it a little bit because it's good for comparison, I think. So you would have a mapping of an address and to like how much that address have of your cryptocurrency, right? And that would be something like balances, right? And then whenever you would have like, there could be a function, get me a balance of, and then you would get an address of an account, and you would make it maybe public, and then it would returns the amount, the balance that that person has. So you would just do return balances, and then do account. Right? Super simple. Oh, what did I do? Account, yes. Super simple. This would work. You would absolutely can do that. Like, you would need to figure out a way to create these tokens in the first place, like what we call minting, and so on. But that's what you would do. Now, when you're doing NFTs, there isn't actually like multiple of them, right? There's just one of the specific NFT. So you have a collection, which would be this contract. Maybe let's look at some examples. That's going to be maybe better. So if we go to OpenSea, which is like, OpenSea is the biggest marketplace of NFTs. Let's click on Explore. Oof, there's a lot of stuff here. But there's this CryptoPunks, right? Those are bigger. I don't know, they should be here, I guess. I guess this looks like Bastard Gang Punk. This looks like a copy, but it will work for us. Like, all I'm trying to do is that this is part of some collection. This one. This collection is a smart contract somewhere, which is the thing we're just building. I'm not too familiar with the interface here, but I assume you would find somewhere. Okay, well, let's just click on one. And this specific token should have an ID. I guess it's this 2785, and that's going to be one line in that mapping of ours. Oh, cool. So here we have the contract address. So we can go to Etherscan. We can go here and see, well, we could like look into ownership and how this actually works. If we look at the contract itself, which is cool, this is the name of the contract. Can we search for this? As you can see, this contract is also implementing ERC721, and it does a lot of stuff. We could go through it and look into what it does, but that's not important. Let's build our own thing, right? No, but it's definitely a good plan to like go through some public and famous NFTs and just like figure out what they're doing, right? What's the catch? Like, here they're doing something, calculate price, and it looks like the price is basically, just from a first glance, it looks like they're trying to make it more and more expensive the more they print them out, because they're using correct supply and then they're doing some math. So that's their thing, right? But you can implement whatever you want in your NFT. You could, make it cheaper every time somebody sells it, or you can build the royalties in it, or you can build whatever you want. Alright, sorry about that. Let's go back to this. So here we were talking about balances, and we would keep track of which address has how many of these tokens, which would be for the fungible tokens. Sorry, I feel like I'm not concentrated enough today, and I'm just jumping from place to place. But just please bear with me. But in an NFT, you would have a unique one, right? In the case we looked at, let's do this. When we looked here, yeah, right? this is one NFT and it has one owner, which is this wallet address. So we want to build something similar. So in our case, we don't need mapping of address to how much they have, but the more important tracking for us is like a token ID, right, towards the address of the owner. Let's call it this way. Right? So we're saying this token with whatever ID is owned by this address. So if we look at that example that we just saw, sorry, let's do this. I'm going to close this. So in this case, this, where's the ID of this dude? Yeah, this one, you know, that token is owned by this address. Like, this is not the full address, I guess. If we would click it, we will see the another one. So let's try to look at another one. So this is another guy, like another token. So that will be, you know, mapped towards whatever, success. This dude, this person, or bot, or computer. Who knows? And you know, but we would store the real addresses. These are some like names generated by OpenSea, but we would store the real addresses. And we're gonna see in a second. But maybe there's another standard that is good to be aware of, which is ERC721. Let me type it here. ERC721. Well, you can, I guess, read about it some more, but the difference is that in this standard, you don't have just one token per specific ID. So you could have a multiple things. So you can think of it, say you have a game and you have NFT as a wearables. Like, you know, somebody has a pants, somebody has a jacket and stuff like that. Well, hello. I'm not used to doing the chat thing as well, but let's do it. Hello. So yeah, so somebody would have a jacket, somebody pants, but you want to print maybe 10 of these jackets, right? So that wouldn't work anymore because the jacket would be this ID and then you would have 10 people owning it, so that wouldn't work. So if that's your use case, you would actually use ERC721. The thing is that ERC721 is a little bit more complex because it needs to handle this non-fungible and fungible tokens all combined. So it's a little bit more complex. But as we're gonna see, we're gonna use OpenZeppelin implementation of it in the end. And then they have implementation for this standard as well. And then you just need to do a little bit on top. But it's still good to like understand how the underlying implementation works, especially if you want to add something on top of it. Cool. If that makes sense. For this though, I'm just gonna stick to ERC721. So I don't know this site, but I assume that this might work. No? Let's try something else. So this is the standard for, like, I clearly don't know where I'm going with these different sites, but this is the standard. It even has the interface implemented here. It's awesome. Again, read more about this if you're interested. Okay, going back to the code. So we would have this mapping of who owns what, right? This token is owned by this address. Awesome stuff. So, but then you wouldn't have a function balance off, but you would have a function owner of. Oops. Owner of, and then you would send the token ID in it. 256. Boom. Token ID. Oops. This looks good. And then it will be public. and then it returns address. Boom. And then again, we can do just very simple implementation here. Oops. Okay, and it's called owners. Perfect. So now it has this squiggly line, because this function call doesn't have any mutability, as it's not changing state on the blockchain. This is an important distinction, because that means that we don't need to make it, we can make it as a read function. So you can read here, view. Because these read-only view functions, you can call them anytime from the node, just by reading the state of the contract. So you don't need to send a transaction. And also means you don't need to spend gas to call this. So you can call that anytime, it doesn't cost you anything. If it's a view function, if it doesn't mutate the state, so if it doesn't change the state on the blockchain. So all these like read-only functions, they would be view. So that means you can call them anytime, it maybe in your application, even without person clicking anything, you can look up who the owner of this token is, right? And you don't need to spend gas on it. So that's the important part. If you would do something like transfer, let's see. Let's say we would want to like send token ID to this address, right? Here we of course would need to change the state, because we need to change who the owner is. Like what you would do is you would do owners of this token ID equals this account. Obviously right now we have like a huge bug here because really anybody can call this transfer. It doesn't matter if you own this token or not. Like you could be this account and send this function and ask for this token. So what you would do, you would like do require here and check that the owners of this token ID is equal to message sender. So not your to give. So what I've written here is that if you call this method and you're not the current owner of the NFT, you get an error back. You will not transfer the ownership, if that makes sense. Cool. Let's write one more function just to try out things. And this one's gonna be called mint. And what we're gonna do here is we're gonna create a new token. So what we want to do is do like owners, right? New token ID equals message sender. So what the new token ID should be here, right? Well, that's up to you, how you want to put IDs on them. And you also need to kind of figure out how to do this. So in our case, let's just use like a total supply. Like we're gonna keep track of how many tokens we have, and then we're gonna use that as an ID. So if we have a 0, we're gonna use 0 as the first ID, and then we're gonna increment it every time we mint new one. So the next one's gonna be 1. So for that we would have 25.6, which is total supply. Oh yeah, also these guys should be private, or like it's up to you, but you should decide if they're private. I guess this default should be private, but I'm not sure. Cool. So now we can say, let's do this. Boom. So this now works. We also want to increment total supply by 1. So then next time the ID is going to be 1. I hope that makes sense. Also note, it's a transaction, so this is going to be so-called atomic. It either happens all of it or none of it. If there would be any problem at any step ever, we're going to revert everything in here. So if this would execute, but here we would have some fatal problem, we wouldn't end up in a broken state where the total supply wasn't incremented but it was already minted. It would just roll back everything. Cool. So that's what I wanted to say as well. Well, I guess we're kind of ready to try this out a little bit. So what's the best way to do that? I guess here down in the terminal we can try to write Truffle develop. Let's see what happens. So Truffle develop lets you start your local blockchain. It's not real blockchain, but it's running on your laptop. You're the only contributor, you're connected to the node, and you can write stuff. You also get 10 accounts at the beginning here. Let me make this a little bit bigger. You get 10 accounts. If we look at... By the way, the thing I'm typing here, that's JavaScript as well. Or as well, we already started it before, but this is JavaScript. And you get a Web3 library already like imported here, so you can use it. And then you also have autocomplete, so you can press tabulator to kind of see stuff. And then what you can see, you can do get balance, and you can use one of the accounts, right? We got 10 accounts, it's an array. Now we're saying get me 0th account, and let's look at the balance of it. And it tells you that it's this amount. So this is a pretty big number. That's because all the values within, or let me rewind, that's because blockchain sucks with float numbers. Or like, let me rephrase that, every computer sucks with float numbers. Float numbers meaning non-integers, like when you have 1.5 or something, where you have the point and something. It's not good for computers, and the reason why it's not good is that the computers have a limited space in the memory that they save to like store this number, and then they use this, and that limits the precision on which they can go, and sometimes that can lead to very bad stuff. Like you would compare 1.3 with 1.3, but it's not equal, just because you lost the comparison somewhere. Like because it would be 1.3 really equals 1.2999999 for some reason. We don't need to go too deep to that, but the way you would get around it is that you say, okay, so I care about some precision. In this case it's 18 places. So after the decimal point, you have 18 places of precision, and then you do times 10 on 18th, I guess, so that you shift all that before, and then you store this whole value. And when you want to show this somebody to some person or some website, you would again divide by 10 on 18th, and then you shift it back, and it's again like a nice number. There's also this utility you could use, which is from Wei. Wei is the smallest what's the name of it? Like the smallest value. Like you have Ethereum, and that has many Weis in it. So that's the actual number we're seeing here. That's the Weis, number of Weis in it. And we can take it, put it here, and I guess it wants string. And this gives us that it's 100 Ethereum. There's also the opposite way to do Wei. You could do what's 2.5 Ether in Wei, and it will, you know, do this for you. So that's that. So we have these accounts we set. Oh yeah, one thing we forgot to do. So the next step I was about to do is deploy this contract and play with it. But because that wouldn't work, because we forgot, or I forgot to write the migrations for it. So migration is a JavaScript program that tells Truffle how to deploy this smart contract. So what we can do is copy it, boom, paste, rename to, call it NFT. Numbers, it goes in sequence. That first does 1, 2, that's why you start with numbers. And then here I'm pressing Ctrl D to mark all the names, and then replacing with our name. So basically, get BeaverNFT from BeaverNFT, like this file, and then we here do deploy BeaverNFT. This is perfectly fine. This is all we needed. So we're just gonna do deploy. Okay, sorry. I'm gonna go back down here. And we're gonna run deploy here. So now it should run those two migrations. Cool. And now we can, if we look here, it was deploying BeaverNFT. Here's our new contract address that we're gonna interact with. Yeah. Also, one thing, cool thing. If you look at the balance of account 0, it's no longer 100 Ether, and that's because if you don't specify which account to use for whatever we're doing here, it's going to use account 0, like the first one in the array. And because we deployed contracts, we use some gas to do that, so that's why the balance is lower here. But it's, in this case, it's a very small amount, so we don't need to even worry about it. And it's super fake Ether, so it's fine. Anyways, so now we want to get an instance or like a handler of this NFT contract that we just deployed, so we can interact with it. There are two ways you can do this. So the easy way is to do this thing, BeaverNFT, and then deploy it. So what is this line doing? So we're saying create, this is JavaScript, const this means it's not going to change, create a contract by awaiting everything we're going to do is asynchronous calls because they go to blockchain. Here we're working with local blockchain, so it's like instant. So it seems like synchronous, but it's not really. When we're gonna do later like a real blockchain, we're gonna hopefully do Rinkeby test network. We're gonna see that this actually takes time. So you can do deployed, which was the last deploy contract, or you could do also add, I think, yes, and then you paste in the address here, right, which we got from here. So this would be useful if you're working with a test network and you've already deployed it, like last time, and you want to work with the same contract. You can just do this. Oh, I didn't copy it. But this would be the contract address. I just do this, and you also get an instance of that same contract. So now we could do, you can say mint. Right? This was our way of minting. If we look back in our NFT code, we had this mint function that should create a new token. In this case, token 0. So now if we look at who's the owner of contract 0, it's gonna return this address, which if we look at account 0, you know, it's the same address. Now we only minted 1, so what would happen if we do owner of 1, or like owner of 5, which is not existing token, we haven't minted it yet. If we do that, we get 0 address. And the reason for that is that all the fields or all the values in Ethereum, they're always, all the primitive fields like UID and address, they're always set with the initial values. So, you know, all the numbers, they're gonna be 0, and so on. All the booleans, they're gonna be false at the beginning, I think. Yes. So that's why you got zeros here, although this thing doesn't exist. So correctly you should, you know, do require maybe here and then throw if it doesn't exist. Cool. So one more thing we can try. We can try to use another account. So let's do contracts here. And let's do mint. But say you would like to mint it for another account. So you can send another parameter here, I think, and you can specify the, you know, the account you're sending this from. So you can do this. Sorry, accounts. You can do this. This worked. And now if we look who owns number 1, and then, you know, those are different addresses. And if we look at number 1, this is owned by account Sal. See, this is same address as this. Why? It's because we've done this, right? We said send this from accounts 1. Because as I mentioned at the beginning, if you don't provide the from part, it's automatically going to choose account 0. So this would be equivalent. So this is equivalent to not providing it at all. Cool. And then one last thing we're going to try here is to trigger this error of ours. So let's say we want to, we just, as account 0, we printed this token 0, right? And then our good friend account 1 would like to have that token, but because we are a very kind person, we're gonna transfer it. So what was the, so we're gonna transfer token 0 and we're gonna transfer it to accounts 1. And again, by default we can be explicit here. Let's do that. So we can say account 0. So account 0 is the current owner, so that should be fine. So we do that, we got the transaction. Sorry I didn't explain that, but you get some response, and this is how like happy path looks like. So now if we look who owns 0, it's the accounts 1, right? Not account 0 anymore. So that means that if we again, now we change our mind and then we don't like accounts anymore and we would like to send it to accounts 2. So we could try to do that. But this failed because we no longer own this, right? Not your to give, which is exactly the text we write here. So this is kind of important concept as well. You need to write these require and checks everywhere to make sure people are not doing something that shouldn't be allowed, or you don't want them to do. It's kind of good practice to put a string here, text, to like why it fails, so you don't get like weird errors or anything. But that makes sense. So if there's any question at this point, that would be awesome time to ask. Otherwise I will move on to using the OpenZeppelin implementation. Okay, so let's do that. So this is all well and good. Let's get rid of the terminal for now. This is all well and good, you know, seems nice, but we probably made like many bugs doing this because this is probably not a good code. How you can fix it though, or fix it, I mean, what you can do instead is used already tried and solved solutions, which is OpenZeppelin. You could go here, look into, well, let's start from the beginning. Let's go to OpenZeppelin. Boom. So you can definitely come here, and you would somewhere go here, contracts. OpenZeppelin is a company, they're doing awesome stuff, but among other things they provide these open source contracts or standards you can use. So you can get started, read about how to use them. We've already used them in the previous video, which is now on YouTube, ERC20, how to do cryptocurrencies. But basically you take this JavaScript dependency, so we're gonna do that, and in our code here, let's go back to we just npm install this thing. Cool. And then if we look here, what it did, it created this node modules folder, if you're not familiar with JavaScript at all, and then downloaded a bunch of stuff, including this tokens folder, and here we have ERC721. So let's take that. So this is the one we would like, ERC721. So let's copy relative path to it. Let's go back here. This is now we're back in our contract. What you do, you read import statement. Oh yeah, sorry, I was maybe too quick. What I've done here is I right clicked and then I copy relative path to it, and then I paste it here. You don't need that node modules part, so I'm just going to drop it and do this. You could also follow the documentation. Alright, well, it's exactly this line, what I've done, right? So you could do that as well. Alright. Okay, so let's get rid of all the code we've written. And let's use another construct in Solidity, which is inheritance. So you can say is ERC721, and that means this contract that we're just writing inherits from ERC721, which is the NFT standard that we talked about. Now you got some squiggly lines, and that's because this should be marked as abstract. So let's mark it as abstract. No, sorry. So why it's doing that is because ERC. Well, actually, if we do Truffle compile, it should give you more information, like why it's complaining. So here it says contract should be marked as abstract because yeah. So here we go. Missing implementation. You haven't implemented this constructor. And that's, if we look at ERC721, it has this constructor with two fields in it, like the name of your NFT and the symbol. But because we haven't done that, let's do it. So what you would do, constructor, boom, and then this is a standard way to doing constructors, but if you want to initialize call constructor of one of your parents, you would just do this and then you send arguments here. So the name of our NFT would be BeaverNFT, and the symbol could be BNFT, whatever, doesn't matter in this case. Probably matters in your case. So now the squiggly line's gone, because this is fine now. This is all good, so perfect. Let's look at what we've got with this. So there's a lot of stuff to go through, and that's because these standards, they already cover most of the use cases you're gonna need, and they also do a lot of checkings and security-wise stuff. But we can see that, for example, it all stands from this owner's mapping, which is the thing we started about. Like, who owns what? That's the crucial thing. That's the thing you want in your ERC721 token. So they do that, and then they do much more. There's some token approvals, which is like you delegate the right to somebody, transfer your token to somebody else. this is kind of required for marketplaces. So what you do, you delegate the smart contract of the marketplace to transfer your token if the person buying it pays enough money, right? And then you don't need to send a transaction to transfer the token. The smart contract will do it. Yes. One thing I wanted to point out to, like, obviously if you would be doing your own NFT, you should get familiar with the structure. I read through the whole file probably. Is a very good point. This is important thing. So this is this virtual internal method to mint. So nobody from external, meaning like nobody when it's deployed is going to be able to mint anything. But we want to still create some tokens in the first place. So how do you do that? Yeah, so you would create a function for it, the same way we did before, right? You can create a function called mint. Now I'm a little bit sorry that I deleted it, because we had this awesome function. But instead of me touching the internal fields of that ERC721 directly, I would just call the mint here. And then if we look on the mint function, it actually takes two parameters: who's the recipient of the new minted token and what's the token ID. So we can say that the recipient is message sender, so the person who calling these methods is gonna get them, but what's the token ID? Now we have the same problem, so let's do the same solution, which was OpenSea256. So we're gonna do the total supply thing again. But this time let's make it public, so that people can query how much there exists of it. Yes, and then we do total supply +1. Boom. So this is perfect, right? One thing to note, we added this total supply, but it's outside of the standard. So like marketplaces won't actually know what the total supply is unless they also implement it somewhere. But I don't think so. They can of course have a centralized server that would index all the transactions on that contract, and from there figure out how many there are in the real world. But you could also expose it. But that's not important. Now we have pretty good NFT actually. You can mint, and we get all the other functions from ERC721. So you can transfer, you can look who's the owner of that, and so on. So next step, let's actually deploy it to a test network and see how that works. Cool. So to do that, we would go to Truffle config actually and uncomment one of these things. So here in the Truffle config, there's a networks section which you specify which networks we want to connect and how to do that. I've uncommented this section, because that's one of the Ethereum test networks. We're gonna use a different one called Rinkeby. Yes. We basically don't need these things, don't worry about them. And obviously this is Robston's ID, so that's not going to work for us. We need ID 4, which is a Rinkeby's ID. One more thing is that we have this HD wallet provider. So why is that? When we used to develop, we created our own blockchain or our laptop here, and we created accounts with it that we could use to create accounts and stuff, create contracts and so on. But now we're creating to a public blockchain, granted a test network blockchain, but still public. So you don't get to create already funded tokens on accounts on it. But what you can do is have already existing accounts, have their private keys, and map them to this provider, so that you would use real accounts that have a real Ethereum balance on them, so that you would use those accounts to pay for the gas, which is exactly what we're gonna do. So how do you get this? So this is like a class, JavaScript class that lets you operate over Rinkeby network. Let's quickly set it up. I think I walked through this last time as well, but we need this dependency, so let's fetch it. So here we're just gonna do npm install and this thing. Whoop, whoop, whoop. So while this doing that, we can uncomment this line. Nice. Another thing is that we need the private key or mnemoig. Mnemoig is a way to, it's a 12-word phrase, it says here, and we would generate the private keys from it. But what we're gonna do instead, what we're gonna do instead is we're gonna create, we're gonna use private keys directly. But still, it's a good idea, something what they say here. Create a secrets file or something. I'm just gonna create a secrets.js here. And I'm gonna make a new file here, call it secrets.js. And here we're gonna do module exports, boom, boom, boom. And we're actually gonna, do the private keys here. So private keys, keys, and an array, and that's what we're gonna export. So you would have, whatever the private key is, 1, 2, 3. Cool. And then in here we hopefully can do private keys. Yes. And then this file you would not commit to your Git repository. You would git ignore it, keep it on your laptop to never leave it. It's because obviously whoever has your private keys has your life. So what you can do here is you can say private keys, and then private keys, and then URL of your node. So how do we get that? One thing they're saying here you can do. Boom. By the way, I changed the call. This has two constructors, this class. Either you provide two parameters, which is the mnemoig and the URL you want to connect, or you provide one object which has a keys values, because there's much more you can set here. Like there are many other things, but we just need those two. So that's a different way to configure it. One thing they're saying you could do is use Infura, which is very, very much true. We're gonna do that. When we used to develop the local blockchain, we had the local node running in our laptop because that was all of the nodes actually. When we're gonna do testnet fork, we need a way in. We need one of the node of the networks and connect to that. Infura is a service that lets you use. Okay, I don't have it open. Let's open it. It's a service that lets you. That has the nodes in all the networks. Gives you APIs to connect. I'm logged in. Cool. Connect to that network and use it. So you would create a project, and then after clicking around, you would go to here, and then you take Rinkeby, and then you copy this endpoint, and that's your endpoint. Boom. So we can go here. Cool. This should be it. Now, down here in the terminal, we should be able to just run Truffle deploy, and then you specify a network you want to do. If it's not developed, by default it's developed, but we want to do Rinkeby. So you could do that. Obviously I didn't put my private key there yet. So it couldn't create the private keys because mine was just nonsense. So I'm just gonna do that real quick. I'm gonna switch screen here so you don't see. Obviously I'm using just a test network. Oh yeah, let me show you how to get that actually. So how to get that? You would go to your MetaMask plugin. You have one account. This one, I'm on the Rinkeby test network. So you would go here. You would show or hide your test networks if you don't have them shown here. But I would go to Rinkeby. What did I do? And then you have your account. You probably have 0 here if you just started. Then you go to Rinkeby faucet. Go here. You follow instructions on how to get the ether. Cool. So I have these 2 accounts. This one has some ether in it, like not much, but hopefully that's going to be enough. And then I can go into details and then export private key, and here you need to type your MetaMask password to show it. That's the part I'm not going to show you, but I'm going to do it. Account details, boom. Alright, and we're back. So I changed in my secrets file here, I changed the private key, and now when we run this, hopefully that's going to work. So let's give it a try. This looks pretty good. It's already starting doing stuff. It's deploying migrations. This might take a little bit because, as we said before, now we're interacting with a real test network. So, it actually needs to do all the blockchain stuff. Wait for a miner, the miner will mine this block with the transactions that creates the contracts in it, and then wait for all the confirmations that it actually happened, and stuff like that. So now, I don't know what it was doing before. Oh, okay, look at that. It was doing dry run, so it was doing simulation before. Now it's doing it for real. Let's see, how does that go? I think we can also check while we're here. If you open our MetaMask, you can the account and Ether scan. So this is our account. You see that there's few seconds, which is what my Truffle is doing stuff here. Also, one thing to note, here it says Rinkeby test network. Here is a way to switch to a different network. So yeah, just as you know. And this is the address that I'm doing this from. It's creating some contracts, as you can see. We're gonna look some more. So cool. So now it's finished here in Truffle. Let's see if here we're already done as well. Looks like this, the second contract, might be it. Yeah, this looks pretty good. So this is probably the contract. Actually, let's look at Truffle, right? It told us deploying BeaverNFT, and the contract address is this thing. I'm just copying it, but 57F at the end. If you look at there, 57F at the end. So this is that. Now, how do you interact with it, right? We want these NFTs. So how do you do that? You do Truffle. And we used to do develop, but now we're going to do console. So there's a slight difference between those two. The develop will start the development blockchain and connect to it, while console only connects to blockchain. And because we're trying to connect to testnet fork that already exists, we don't need develop. We just need console and then network Rinkeby. Boom. So this will use the configuration we've done here in the Truffle config, Rinkeby, and connect there. That also means that the accounts array that we get has the accounts that we provided as these private keys here. So it has only one account because I just put one there. And we can do, all the same things. Like we can do Ethereum, get balance of accounts 0. And that's a fairly small number. It looks big, but it's not. It's less than 1 Ether. Right? So if we look here, right, it's 1651. Wait, which matches this, right? It's just shifted because of the discussion we had before. Anyways, what we can do is we can fetch our contract instance again by saying NFT BeaverNFT deployed. Cool. And then we can do contract mint, right? Let's mint one. Boom, boom, boom. Yes, so as you can see, this takes a little bit of time. This looks pretty good. We got successful minter. Let's mint one more, just for fun. But let's go, while this is happening, we can go back here. This is our contract, and you can see that we see this transaction happening because this is the real, testnet thing right here. Yes, so this is good. If we got, this is my address that was sending all that. I wonder if you see it here. Yeah, you do. Awesome. So you can, on the Etherscan, because it recognized the standard of the contract that it interacted with, it shows you all the NFTs it bought, or minted in this case, right? All the transactions or transfers that touch this wallet. Pen is a thing I tried before because I just remember a meme, which is in the Wolf of Wall Street, I think. It's from there, where Leo asks some person, can you sell me this pen? And then I saw the pen and the person said it's NFT. So that was kind of, I found that funny. So that's why I use pen. Anyways, this is the real one, BeaverNFT. We got 2 tokens. Amazing thing. Let's do one last step, which was the OpenSea stuff that I promised. Well, what am I doing here? This is the token. This is the contract. Cool. So I want to copy this address of the contract of the smart ERC721 smart contract that we just deployed, and I want to go on an OpenSea and sell it. So OpenSea, I want to say new listing. I always find it hard to find this place. No, it's none of that. Should have stored it. Get listed here. Yeah, but that's not exactly right. This is for production. I actually found it strict, so you just, it's this is the URL you want to go to, get listed. And here I can choose live on testnet, like live on testnet. My contract is live on testnet, so that's true. Let's go here. You can choose the testnet you want, in our case Rinkeby, and you just paste the address of the contract. It's easy as that, and then you submit. And because our contract is implementing ERC721, OpenSea knows how these contracts, how to interact with it. It knows that we have 2 of them, and it knows the name of it, right? This is pretty cool already. Like, you can click on it, and you can probably see, created by you, what? You can probably see who the owner is somewhere. Man, I really should learn the URL. Oh, owned by you. I guess it knows that it's me somehow. Yeah. Well, anyways, so you would log in here with your login. Oh yeah, so it already knows that it's me. When you click this, you can log in with your MetaMask. Let's try that. Can I log out? Log out. Cool. And then if you want to log in, you click MetaMask. And it should... Didn't ask me because it's already connected. So let's disconnect it, maybe. I want to show you from the beginning. Right? So if we go back, we see that it's owned by this person, whoever this is, right? And then if we click the wallet, we can click MetaMask here, and you choose the account. Choose the account that you used to create it in the first place. So account 2 in my place, in my case. And now we're connected. I can see it's mine, and I can sell it, right? Because I own it. And then they have a servicing fee and stuff like that. So you would look at that. That's pretty amazing, I think, that it's so easy to do. For production, you would just follow exactly same procedure. You would just use here, you would use a different URL for Infura, like the production one. You would use a private key of an account that has real Ethereum in it. And that's it. And you're all set. So you would deploy this, you would not, point it to testnet, but to production, and it's all good, and it all works. And you can start selling your cool NFTs. One thing we haven't talked about is the images, right? We haven't talked about metadata, which is a JSON file that contains all the metadata about the NFT. I think I'm gonna do like a video on that as well. But just for information, you will need something called metadata, and inside the metadata there will be a link to this image that supposed to show it. But you could of course use NFTs without image as well. Like say you're building your own metaverse, and then each token ID represents one plot in your universe. Like starting from 0, whatever the number is. Then you don't care about images, right? They have a utility, this NFT. The art in it isn't the thing that you're selling the utility they have. Even in this case, you would probably put some image there, so it's more visual in these marketplaces, but still. Coolio. So I'm gonna stop here, I think. Thank you for your attention, and have a wonderful rest of the day. Bye.